Hello everyone, in this video I will explain you how to find sag or deflection at any specific point. Now let us refer this numerical. Now there is one vertical wall and at point A and D hinge supports are provided and the cable is A, B, C, D. At point B there is force of 40 Newton. At point C there is force of 60 Newton. The distance between point A and B is 5 meter. Between B and C it is 8 meter and between C and D it is 2 meter. Now due to this force of 60 Newton, the point C has deflected horizontally rightward by a distance of 3 meter and the sag at point B due to 40 Newton force, let us say XB, and our aim is to find this XB deflection at point B. According to our procedure, first of all we have to draw separate free body diagram for the given problem. Now look how to draw this free body diagram. So show this shape A, B, C, D, show these sags, show these forces, show these distances. Now how to show these force components and their directions. Now look, whatever is the force in this AB part will be the reaction acting at point A. If you extend this line of action for this AB portion, so your reaction will act in second quadrant, and in second quadrant my horizontal component always acts towards left side and vertical component always acts vertically upward. Similarly, extend this line CD. So if you extend this line in opposite quadrant, it will move towards third quadrant, and in third quadrant horizontal component acts along left side and vertical component acts vertically downward. So this is the explanation to show the direction of these components. Now to start with the numerical, we have to apply equilibrium conditions. So for this I will consider whole cable A, B, C, D. Now I will apply first equilibrium condition, which is summation Fx equals to 0. So for this I have used sign convention as forces going towards right side positive, forces going towards left side negative. So if you observe this free body diagram, this is the horizontal force Ax, 40 Newton, 60 Newton and dx. Now according to my sign convention, my equation will become minus Ax plus 40 plus 60 minus dx must be equals to 0. So equation will become Ax plus dx must be equals to 100. So let us say this equation as equation number 1. Apply next equilibrium condition, summation Fy equals to 0. So for this I am going to treat sign convention as upward forces positive, downward forces negative. So plus Ay minus dy equals to 0. So in short, Ay must be equals to dy. So magnitude will be same, only their natures will be different. So let us say this as equation number 2. Now apply third equilibrium condition, summation m equals to 0. Now you can take moment about A or at point D. So I am going to take moment about point A. So if you observe this point A, this Ax, Ay and dy, if you extend this line of action for dy, all these three forces are passing through point A. So its moment about point A will be 0. Now take moment of remaining forces. Now after taking moment of these remaining forces, now look 40 Newton, how it is going to rotate about point A? It is going to rotate in anti-clockwise direction. Okay, this force 60 Newton, again it is going to rotate in anti-clockwise direction about point A. Now consider this dx force, it is going to rotate in clockwise direction about point A. So since these three forces are horizontal, consider its vertical distance with respect to point A. Now look, 40 Newton force. So sign convention is clockwise moment negative, anti-clockwise moment positive. So plus 40 into 5. Consider this force plus 60 into distance 8 plus 5 13 meter dx minus dx into distance 5 plus 8 plus 2, so it will be 15 meter equals to 0. So from this unknown is only dx. So from this you will get value of dx and it is acting towards left side according to free body diagram. Now use equation 1. Equation 1 is ax plus dx equals to 100. Already we have calculated value of dx. So ax will be 34.67 Newton. According to free body diagram, it is acting towards left side. Now next part we have to find values of ay and dy, and for this we have to consider part of cable. Again there will be question in your mind, which part of cable you have to consider. Already I have explained you have to consider the part of cable where sag or deflection is given to us. Now if you observe this diagram, sag at point C is given to us. So we have to consider part CD of cable to find value of dx, and from this we can calculate value of ax. Now I have considered this part CD of cable. There is force of 60 Newton. This sag xc is 3 meter. Show these components dx and dy. Already we have calculated this force dx, and the distance from point C towards point D, it is 2 meter. Now take moment about point C. Why to take moment about point C? Because if you take moment about point D, moment of these two forces will become 0 and we have to determine the value of dy. So let us take moment about point C. Now look, this moment will become 0 about this point. Now if you consider dx force, it is going to rotate in clockwise direction about point C and its distance is 2 meter from point C. Now consider this dy. It is going to rotate in anti-clockwise direction about point C and its distance from point C is 3 meters. Now use this equation. Moment about point C must be equals to 0. So according to sign convention, clockwise moment negative, anti-clockwise moment positive. So minus dx into 2 plus dy into 3 must be equals to 0. So what is unknown? Unknown is dy. So from this you will get dy, which is 43.55 Newton, and according to free body diagram it is vertically downward. Now use equation 2. We know ay must be equals to dy. So magnitudes will be same, only their natures will be different. So ay will be 43.55 Newton and it will act opposite to dy. It means vertically upward. Now next part, I have to find sag at point B. So for this I will consider AB segment of cable. Now show these two forces AX and AY. Now I know value of these two forces. At point B there is force of 40 Newton. Now this is sag at point B, which is XB, and the distance of point A from point B is 5 meter. Now let us take moment about point B. So summation MB must be equals to 0. Now according to sign convention, look, this AX force is going to rotate in anti-clockwise direction about point B and its distance from point B is 5 meter. So it will be plus AX into 5. Consider this AY force. It is going to rotate in clockwise direction, so it will be negative. So minus AY into its distance. Now force is vertical, so you have to consider horizontal distance, which is XB. Now in this equation I know value of AY, AX and this length. Unknown is XB. So by using this equation you will get sag at point B, which is XB, and it comes to be 3.98 meter. Hope you have understood this numerical. Thank you.